So this is an example of the output displayed when an assertion exception is thrown. You can see that this is an assertion error and trace it back to your Java code. When you do implement your catch statements, basically when you develop your own exception handling technique, the choices that you have is to really just to terminate the program if it's an unrecoverable error, but you should probably display an output of a helpful error message before termination. Another possibility is to be able to fix the problem, somehow recover, and let the program to continue. This may be a typical situation where you're trying to get the user to give you the correct input. Again, this could be mixed with displaying appropriate error messages and keep retrying until the user enters the correct value. And on the server side, you can just write error messages into log file and continue program execution. When errors are detected or a user reports a problem, somebody can examine the content of a log file, which then becomes a starting point of the problem investigation. If you want to create your own exception classes, just remember that Java offers two general types of exceptions, the checked and unchecked exceptions. You should use a checked exception for all errors that are expected and should be handled by the application. So the checked exception is what you should use for your custom exception classes, meaning that you should make it a subclass of the exception class in Java library. Using exception mechanisms does not automatically eliminate software bugs. So using assertions as well as ability to debug your code in interactive debugging sessions is still part of your job as a programmer. While first meaning of debugging is to remove errors, its real meaning is the ability to see the execution of the program. When you're creating a program, you're making many assumptions about its execution, and this is a necessity since it is impossible to see what program will do before it is written. Some of your assumptions could be wrong and will result in code errors. Even if the code compiles, you might still get a strange behavior at runtime. Solution to this problem is to add visibility of the execution, gain control, find precursors to the problem, and finally remedy the problem. Okay, if you found the problem and now it's time to fix it, however, remember to make one change at a time. Do not attempt to change too many lines of code at once. One change at a time is really just the only known specific approach to manual debugging. And sometimes you need to take a break when you have to, and ask for help from your teammates if you're getting stuck on an unexpectedly stubborn problem.